Hello, we are discussing about GATE 2009 ECE paper. Look at the circuit. The circuit is supplied with a RMS voltage of 20 volts. So given voltage is directly RMS voltage with internal impedance of 1 plus 2j ohms, and that is feeding a load of 7 plus 4j ohms. Find the reactive power consumed by the load. Reactive power consumed by the load. So if you observe, there are three different variations in the power that we can get from the power triangle. Power triangle says, okay, this is the power triangle, and power triangle says that one, this is power factor angle theta, okay, and opposite is Q, and this is S, and it is P. S is called as apparent power, or it is also called as complex power, okay, whereas Q is reactive power. And units for this one we will see this, okay. P is called as actual power, or real power, or effective power, okay, or average power, okay, or true power. So P is going to be called as either actual power, real power, effective power, average power, or true power. Q is called as reactive power, and if the element is inductor, then it is called as QL, inductive reactive power. Otherwise, if the element is capacitor, capacitive reactive power, okay. And S is apparent or complex power. If you observe units for this one, apparent power has the units of kVA, kilovolt amperes, and reactive power will have a kVAR, okay, kilovolt ampere reactive, and true power is kilowatts. So these are the units for the corresponding elements, okay. We are going to calculate reactive power, and we know the equations for this, okay. P is equal to I square R, because actual power or true power, that is going to be the power delivered to the resistance in the load, okay. Only resistive element in the load, how much power is delivered to the resistive load, that is indicated with P. P is equal to I square R, and I is nothing but IRMS always, and Q is inductive, Q is reactive power. It may be inductive or capacitive. By that time, IRMS square into X, that X can be XL or XC depending on the element, and S is equal to, generally S is complex power. So complex power is defined as P plus JQ, and this is given as V into I. P is equal to, according to trigonometry, you can write as P is equal to VI cos theta, otherwise simply S cos theta, okay, or Q is equal to, you can write as S sin theta from the trigonometry, or S is equal to VI sin theta. And remember that one, V is also RMS value, I is also RMS value. Here S is equal to V into I, V is RMS, I is RMS, okay. Now you have different formulas, which one you have to use? Always you will be getting confused which formula you have to use, okay. Even if you find the solutions, some may be using this formula, okay, some books are using this formula. If you use this formula, you will get different answer. If you use this formula, you will get different answer. Which one can be the right answer, okay? So remember that one. This complex or apparent power is for entire circuit, that is V into I. V is the voltage supplied to the circuit, so this is total voltage supplied to the circuit, and current is nothing but the direction of this one I. So entire current, that is total current delivered by this voltage source. So this power is going to be always treated as complex power or apparent power. So this is related to the circuit level. Once you know circuit level entire power, then the total power is a complex which will be consisting of real power as well as reactive power, that is imaginary. Okay, so real power can be calculated with S into cos theta. Imaginary power, that is reactive power, can be calculated as S into sin theta. So these two elements are also related to circuit level. Circuit level, not at individual element level. Individual element level. Remember this one. It is very, very important. Okay. Whenever you are going to use S is totally related to the entire circuit, and from that one, if you are able to calculate Q, this is circuit reactive power. That is, out of this total complex power, what is the total reactive power supplied to the circuit? So if you use this equation, then the answer is wrong for this problem, because it is asked about the reactive power consumed by the load. Load is an element, it is not the entire circuit. Load is an element which is not the entire circuit, so you must not use this formula. Okay, and if you use this one, P is also, it is also a circuit element. Total resistive power delivered to the circuit. So whenever you are talking about entire circuit, then only you must use P and Q. If you are going to talk about individual elements like load or source or some other element, you may be getting like this. Okay, so by that time, if you are going to talk about individual elements, you must use these formulas. These formulas are going to be related to the individual elements. Okay, so P can be calculated as I RMS square into R, or simply V RMS square by R. Q is also calculated. Okay, reactive power of given element is nothing but V RMS square divided by R, divided by X. So you can use these formulas at individual level. These formulas can be used, okay, both individual element level, elements present in the circuit. Now we are going with ZL, and remember that one, IRMS is nothing but RMS current flowing through that particular resistor, that particular element, reactive element. Okay, so current flowing through that particular element, if you know, then you can calculate the power related to that element. VRMS is RMS value, that is RMS voltage across that particular element. VRMS square, whenever you are using like this for individual elements, they are the voltage across that individual element. It is not the entire voltage. So if you are by mistake, if you are using this formula, you should not use it as 20 square by divided by R or 20 square divided by X. This is wrong. Okay, where 20 is the entire voltage, but what you are going with VRMS is RMS voltage across that resistor. This is RMS voltage across that reactance element, that is, it may be either L or C. Here also IRMS is the RMS current flowing through resistor, RMS current flowing through reactive element. Okay, now we are going to look about the actual problem. So the reactive power consumed by the load, is simply power consumed by XL. If you write ZL is equal to, you can able to write R plus JXL, and ZS is equal to RS plus JXS. So we are going with individual element. In that one, reactive power consumed by this reactance, that we are going to calculate. So power consumed by XL we are interested in. Power consumed by XL is equal to simply I RMS square, that is current flowing through this individual element, RMS value square into XL. This is what we can write, and we know the XL value is J4, so XL value is 4. So we are going with I RMS square into 4. So where IRMS can be calculated as IRMS, that is current flowing through this one, which is IRMS. So current coming from this one, since both the elements are in series with voltage source, same current flows in all the elements. So IRMS from the KVL you can write it as 20 volts RMS divided by ZS plus ZL. That means 20 RMS divided by ZS is 1 plus 2J plus 7 plus 4J. So you can write it as 20 divided by 8 plus J6. So this is 20 divided by, in polar form if you are writing, A plus JB can be written in polar form as square root of A square plus B square as magnitude, and the angle is tan inverse B by A. Tan inverse 6 by 8. Tan inverse 6 by 8 is turning towards 36.86 degrees. So 20 by 10 is giving the value of IRMS is equal to 2 into minus 36.86 degrees. But to calculate reactive power of individual element, we require only magnitude. So PXL is equal to power consumed by reactive load is equal to IRMS square, which is magnitude square, into 4. 2 square is 4 into 4, which is nothing but 16 watts. 16 VAR. Units for reactive power is VAR, volt ampere reactive. Okay, so the right answer for this question is B. Thank you.